Alright guys, now in this video we're going to be talking about dividing polynomials. This is where we start reaching sort of our difficulty level, kind of cranked up a bit. If you know how to multiply polynomials, if you were good on the last lesson, you should be relatively okay here. But let's go ahead and look at the basics first. Now these are not problems that you're going to see on a test, the ones I'm showing you now. But these problems are basically the same math that you're going to be doing in these much larger problems. So let's sort of look at these problems. Let's get used to the basics, the fundamentals, because if you can do these, then you're going to be able to do the rest of these questions. Okay? But I want to make sure I broke it down for you. So let's look at 5x to the fifth divided by 5x. Now technically another way of writing this, 5x to the fifth over 5x. You would see it written like this as a fraction. Now my approach to solving these problems is I think about it a little different mentally. In my mind, I'm looking at 5x and I'm trying to decide 5x times what would result into 5x to the fifth. That's exactly what division is. You're trying to find out what that multiple was that would combine with 5x to equal that end result, 5x to the fifth. So here's what I go. Alright, so I see 5x and it's going to turn into 5x to the fifth. So what am I missing from this puzzle? Well, I started with a 5 and I ended with a 5, so I'm not missing that, right? I have x to the first power, but I end with x to the fifth power. Well, I'm clearly missing 4 x's, right? X to the fourth. That's what's missing from this puzzle to finish with 5x to the fifth. Of course, if you multiply 5x times x to the fourth, you get 5x to the fifth. Okay? So the answer, 5x to the fifth divided by 5x, is x to the fourth, because what is it that you're missing? You're missing those 4 x's. Okay? If you do it the more typical way, like this fraction here, you would say 5 divided by 5, which is clearly 1. And don't forget, one of those basic fundamental things with exponent rules is when you're dividing powers, you subtract the exponents. So if you have 5x's on top and you have 1 at the bottom, basically you're going with, you have 5, but you're taking away 1, so you end up with just having 4 x's. Okay? Because remember, you're sort of subtracting those exponents. 5 minus 1 becomes 4. So you have 1x to the fourth, essentially just x to the fourth. Alright, so the next problem. Let's do my approach. Again, this is not really what I write down. I never really write this down. This is just what goes on in my head when I'm trying to solve this problem. Okay, I don't really think about it or write anything down. I just sort of kind of think what's missing to complete this. So here we've got 6x to the fourth divided by 3x to the third. So 3x to the third times something ends up at 6x to the fourth. Also, keep in mind, I can already see this happening, is people writing these backwards. It should be pretty easy not to do that, because the answer should always be the quote-unquote bigger object. So, I mean, that's one way you can always kind of remember it. But 3x to the third times what is going to give me 6x to the fourth? Well, I had 3, but I ended up with 6. Now, keep in mind, we're multiplying, so 3 times 2 would get me to 6. Now, my x's, I had started with 3, but I ended up with 4. So what if I contributed? I added another x in there, right? So my answer, the missing piece, is 2x. Again, if you do it the more traditional approach, you would see, 6 divided by 3 is, of course, 2. And then 4 x's, take away 3, because remember you subtract those exponents, would just be x to the first, right? 4 minus 3 is 1. So that's a more traditional approach, gets you the same result. The next one, 8x to the third divided by 2x. So if you're thinking about it like I think about it, you're thinking 2x times something will end up at 8x to the third. Okay, so what is that something? Well, 2 times something gets me 8. I know that's going to be 4. I started with an x, but I ended up with 3 of them, so that must mean I'm missing 2, right? So we'll have 4x squared. Again, if you're doing it the more traditional way, you can say 8 divided by 2 is 4, and 3 x's, take away 1, 3 minus 1 is 2, 4x squared. And then our very last one, x to the 4th times something as 9x to the 6th. So I don't have any numbers here, right? But I ended up with 9x to the 6th, so I'm definitely multiplying it by 9. I had 4 x's, ended up with 6 of them, so I contributed 2 more, right? It would be 9x squared. Again, the more traditional approach. 9 divided by 1 is 9. And 6 x's take away 4 would be 2. Okay? Either way works. In a real, fluid sense, you wouldn't be writing any of this down. Okay? This isn't some scratch work. Once you become more familiar, more comfortable with this, you really shouldn't have to write any of this down. You should just sort of be spitballing your answers. Okay? But of course, I don't expect you to be there just yet. So if it helps to kind of write it down like I've done, make some scratch work, I definitely wrote this down for a purpose. So maybe you can as well. Alright. This is going to take a while. Anyway, what I'm going to show you now is, that's dividing. If you can handle that, that's good. If you can do these few problems that I've sort of set up here. But we also have to remember that we need to be able to multiply. Okay? We covered this already in the previous lesson, but I'm going to review it because we do need to be able to multiply more in this lesson. Okay? So here, let's distribute, of course, x to the 4th times 5x. That's going to be 5x to the 5th. Right? Because 4 x's and 1x, when I multiply them together, it becomes x to the 5th. X to the 4th times 3 should be pretty self-explanatory. It's going to be 3x to the 4th. Okay, so that should need multiplying those together. The next one, 2x times 3x to the 3rd. Well, 2 times 3 is 6. X and x to the 3rd make an x to the 4th. And then multiply it by negative 5. 2x times negative 5. 2 times negative 5 is negative 10. And then there's that x, of course, part of that term. Right? 4x squared times 2x. 4 times 2 is 8. And x squared with another x makes x to the 3rd. And then 4x squared times negative 1 will be a negative 4x squared. And then lastly, negative x squared times x to the 4th. I'm sorry, negative 9. 9x squared times x to the 4th. So 9, still 9, but x squared and x to the 4th makes x to the 6th. And then 9x squared times 2. So 9 times 2 is 18, x squared. All right. Now, if you didn't catch on, you may have noticed this, you may not have, but all of these here are the same as all of these here. And I did that for a reason because that's what's going to happen in our problems, is we're going to be multiplying those things that we got when we divided. We're going to be multiplying that back into something, and we're going to get this as a result. So this is sort of like a weird, sort of broken up problem in a way. But that's sort of the process. But now let's look at all of the steps. Okay? If you can do these two things, if you can divide and you can multiply, you can do these next few problems, but these problems are very meticulous in sort of the order in which you do things. So there is a process, and we'll talk about that process. Okay, here you can kind of see what an example of one of the problems look like. It does look a bit fancy and odd. The main point of this picture is the vocabulary, but I'll show you all these pictures or how all this stuff works in a minute. Okay, we're going to do a problem just like that. All right, I'll come back to this problem. There's something about this problem that I don't like as a starting problem, so let me... you can see the answer, but I don't know if you can understand it just yet. We'll come back to that in a moment. Let's do this one first, simply because what we need in these problems is first to make sure that these are in standard form, okay? From biggest degree to smallest degree. Now here's a quadratic, and it's the biggest degree x squared to the smallest degree 8x and minus 12. So it's in standard form, and this is also in standard form. We really, really, really need that to be the case. All right, so since this is already in standard form, that's why I want to go ahead and do it first. Okay, the next problem, or the problem we just skipped over, we can do that second, but it will need to be written in standard form first. Alright, so how we're going to set this up is, since this is our divisor, right? I guess it's a technical term for it. We're going to write this first. We'll have 3x plus 1. And we're dividing it into 15x squared plus 8x minus 12. Now, don't get too freaked out by this whole thing. We're not doing this whole 3x plus 1 into this all at the same time. No, we're definitely breaking it up a little bit simpler than that. Alright, we're going to focus our attention on this x term here, and then we'll do each of these one at a time. Okay, we're not going to try doing everything at once. You can't. That's not how you would solve these problems. So let's start with the 15x squared. So my thinking is we're doing, okay, 15x squared divided by, hold on, we're technically doing 15x squared divided by 3x. But instead of having to do it, like I said, on scratch paper, writing it over there, I kind of like to think, you know, what are we missing? What fills in the gap here? So 3x to make 15x, well, what are we missing? We'd have to multiply it by 5, correct? 3 times 5 would get me that 15. And then think about the x's. Here's an x, but here's 2 of them, so we're missing another x. So that's going to be 5x. That's going to go up there in the top. Okay? Now, if you write it out on the side, of course, you'll get the same thing. 15 divided by 3 is 5. 2 x's take away 1. It'll just be a single x in the first. So you get the same result. But we're going to already use plenty of paper to solve this problem. I know, so I don't really want to take up too much space with this scratch work if I don't really need to. Okay. All right, so there's that. We have the 5x. Now, what are we going to do with the 5x? We're going to multiply this 5x back into this binomial, those two terms. So 5x times 3x is going to be 15x squared. Now notice where I'm writing it. I'm writing it right below my problem. Alright, but of course I have to multiply the 5x as well. It's sort of like distributing to the 1. 5x times 1. 5x times 1 is 5x. Alright, so it's there. Now the next thing that we're going to do, let me erase this because it's not really something I should be writing, but I just want to make sure you knew what I was looking at, is we're going to subtract these things, both of them. 15x squared minus 15x squared is going to be 0x squared. These should always cancel out. Okay, we shouldn't have anything here. That's supposed to happen in this problem if we're doing it right, that those cancel out. Now we're subtracting the next, 8x minus 5x. And if you're wondering why I'm saying minus, it's because that is part of the problem. We're always subtracting here. So 8x minus 5x will leave me with 3x. Okay, that's a very, very careful thing that you gotta make sure you need to do. Alright, so we have that 3x. Now what we're going to do, let's go ahead and bring this minus 12 down. Okay? We'll worry about that in a second. But now what I want to do, I'm just going to clear that out of my way for a moment, is do the same thing I just did at the very beginning of this problem. But now, you know, with the 15x squared, we said 3x, you know, goes into 15x squared. We got the 5x at the top. Right? But now we're going to do it with this 3x minus 12. So I have this 3x, and it's going to go into this 3x. So what am I missing? This is a 3x, and this is a 3x. Well, they're exactly the same, right? So nothing's missing. So we're multiplying this by a 1, essentially, right? Because if you're thinking about it like this, 3x times something equals 3x. Well, nothing's changed, so we're multiplying it by 1. If you're thinking about it like this, 3x divided by 3x, you'll notice 3 divided by 3 is 1, x's cancel out. So it's just 1. So that 1 is going to go up at the top, 5x plus 1. This is, by the way, this is pretty much our answer that we're building up here at the top. All right, so now, same thing we did with 5x, we're going to take the 1 and distribute it into this 3x plus 1. Okay, so what's 1 times 3x? Well, 1 times 3x is 3x. Okay, now what's 1 times 1? Well, 1 times 1 is 1. Okay, so we distribute that 1, and now again, subtract this. So 3x minus 3x, of course, that's going to cancel and be a 0. Now, negative 12 minus 1 is negative 13. All right? Now, there's nothing left to do. Right? There's no more numbers to bring down anywhere. There's no more x terms in my answer here. All I have is negative 13 at the end. This is known as my remainder. Okay? All we have to do is add this part to the end of our problem. So you notice our answer is 5x plus 1 up to this point. But we have a remainder of negative 13. So what we're going to do, we're going to have that negative 13 over, and we're going to put it over whatever we have up here, this 3x plus 1. All right, and that's our final answer. It is very tricky at first, but basically we kind of did the same thing 2 times in this problem. The more of these that you do, which we're going to do plenty of them, I know it kind of sucks to say that now, but the more of these you do, the more familiar and easier it gets, I promise you. Okay? Let's go back to this problem here. All right. Now the issue that we have in this problem is it's not set up in standard form first. We want to make sure we write this in standard form. And when we write it in standard form, write any pieces that are missing. And I'll show you what I mean by that. So if we're writing this in standard form, the biggest degree is 2y to the third. I'm just going to go ahead and set this up, by the way. And I'll just put my standard form inside my division bar and stuff. So we have 2y to the third. Now I need the y squared term. I have a negative y squared term, so minus y squared. Now I need the y term. But you'll notice there is no y to the first power term. There is no y term in there. That's okay, but we're not going to skip it. That just means there's 0 y terms. But we are going to include it in our problem here. Okay, we still need to include it even if it's not there. And then we need the constant, which is plus 25 at the end. Okay. So any terms that are missing, like in this case, the y term, we still want to include it in part of our problem. Okay, we're just going to call it 0y. And of course, we're dividing this by y minus 3. All right. So again, focus on this y and focus on this first term. So what's missing? From y to 2y to the third. Divide those. Well, if we start with a y, but we have a 2y to the third, we're missing a 2, and we're missing a y squared, right? Because this is 1y, but it ends up being 3 y's. So we tacked on 2 more. Now take that 2y squared and multiply it, or distribute back to y minus 3. So 2y squared times y will be 2y to the third. Erase that so it's not on my way. And then 2y squared times negative 3. 2 times negative 3 will be negative 6. And then we have the y squared. Alright, so now we're going to subtract these. So remember, this should always be canceling out. 2y to the third minus 2y to the third is 0y to the third, or it cancels. Negative y squared minus negative. You have to be very careful about all these negatives here. That's basically going to become a plus, but negative y squared minus negative 6y squared, or in a sense, negative y squared plus 6y squared would be 5y squared. So that's essentially negative 1 minus negative 6, or negative 1 plus 6. Same thing. All right, so there's that. We're going to bring this term down. Okay, we're not going to bring 25 down. We're just going to bring one term at a time. The next term, basically. Sort of next in line. All right, now repeat the process. Y goes into 5y squared how many times? Well, we started with y, but we're ending with 5y squared. What are we missing? Well, it needs to be a 5, right? We didn't have it here, so we ended up with a 5. So we're multiplying it by 5. And a y as well, because this is one y, but I end up with 2 of them here, so I'm missing another y. So that's going to go up here. Again, this is our answer that we're building up here, one thing at a time. All right, so now, just like we did with the 2y squared, we're going to multiply this 5y squared back to both of those terms. So 5y times y will be 5y squared, and 5y times negative 3 will be negative 15y, right? Because 5 times negative 3 is negative 15. All right, so we're subtracting this now. All right, so 5y squared minus 5y squared, of course, cancels out. 0 minus negative 15, or essentially 0 plus 15, will be 15y. All right, so now we're going to bring down this 25 and repeat the same process over again. We have y, and it's going to go into 15y. So what are we missing? We're missing a 15, right? From a y to a 15y, we would need to multiply it by a 15. Do you see what I'm saying there? Y times something equals 15y. Of course, well, y times 15 is 15y. So, that's what I'm doing, in case you were wondering how I got this 15 up there. Alright? I'm kind of running out of room, so I hope you don't mind. I really shouldn't do this because it's going to look terrible, but let's pretend this is moved over here, okay? 15y plus 25. Alright, now we got to multiply this 15, just like I did the other terms, back into the y minus 3. So 15 times y is going to be 15y. And 15 times negative 3 is negative 45. Okay, and now we're just going to subtract these. 15y minus 15y cancel out, as they always cancel out. And 25 minus negative 45, or again, 25 plus 45, would be 70. Alright, now you'll notice there's nothing left to bring down. This is left over. This again is called our remainder. Alright? So let's look at our answer so far. Our answer, as we can see right up here, is 2y squared plus 5y plus 15. However, we have a remainder of 70, so what we're going to do is just put that remainder over what we're dividing by, y minus 3, and that's our final answer. So this first part of our answer is kind of built from, this whole process of how many times does y go into 2y to the third, how many times does y go into 5y squared, how many times does y go into 15y. That's sort of typical, but then we get a remainder, and that remainder gets tacked on at the end because it's a remainder. Okay? But it goes over the y minus 3 since again, remainders are there because they don't go into it evenly. So there's your final answer. I'll sort of let you see the PowerPoint work it out. Putting it in standard form, this kind of really outlines everything you need to do. That's how we set it up. Now you can see them solve it. Okay. Notice that y times 2y squared is 2y to the third, so that's why they put the 2y squared at the top. And then they multiply the 2y squared to both y and negative 3. That's how they got this right here. Okay? So you subtract it, you get what we got. It's the same problem that we just did, but looking at it this way might help a little bit. When you add them together, those cancel out. Negative y plus 6y would be that 5y squared. Y goes into 5y squared, 5y times. And then again, you multiply this to both of those, and you get the 5y squared minus 15y. You subtract that. So those cancel out. This becomes a positive 15y. You bring down the 25, do the same thing. How many times does y go into 15y? And that's 15. Right? So you multiply the 15 with the y and the negative 3. You get this stuff. But again, when you subtract it, those cancel out. And the 25 plus 45 becomes a 70, there's your remainder. So your final answer is this. Okay? Right here. As we said, this was all what came out evenly when we divided, and then the 70 was our remainder. We put that 70 over y minus 3 because we always put it over whatever we're dividing by. Alright, it's a tricky process. Don't get me wrong, it's a tricky process, but we're going to do plenty of other times, so don't fret too much. Alright, I'm going to stop the video here because, all these problems do the exact same thing. I'm not going to let this video lasts, go way too long. All these problems you do exactly the same way as what we just did. We'll definitely cover them more in class. But this video is meant more as a kind of review video anyway. So I hope it helps. If you have questions, come see me. This is definitely, like I said, something we're going to take our time with. All right, see you in the next one. Thank you.